So let's try another example. This time we're rotating the graph of y equals x cubed around the x-axis. So our f prime of x is 3x squared. Our f prime squared is 9x to the fourth. 1 plus f prime squared is 9x to the fourth plus 1. And the square root of that, 1 plus f prime of x squared, is just the square root of 9x to the fourth plus 1. So our surface area is the integral from x equals 0, x equals 1, of 2 pi f of x. So I put 2 pi. Now f of x is x cubed, so 2 pi x cubed times the integral of 9x to the fourth plus 1 dx. Now this looks like a rough integral, but it's actually not so bad, because if you notice, we've got 9x to the fourth plus 1 under the radical, and the derivative of that would be 36x cubed, and we have an x cubed outside. So what we can do is we can let u equal 9x to the fourth plus 1, and then du is 36x cubed dx. And so what this converts into is, I guess I can write dx, or x cubed dx, is 1 over 36 du. So that takes care of the dx and the x cubed, and I'll put the 1 over 36 outside, so 1 over 36. I'm also going to put the 2 pi outside, 2 pi. We still have the integral from x equals 0 to x equals 1. Now, 9x to the fourth plus 1 just turned into u, and then we have du. So that's really a very simple integral now. This is, I guess, pi over 18. U to the 1/2, that's just like u, or u, square root of u is the same as u to the 1/2. And if we integrate that, that integrates to u to the 3/2 divided by 3/2, or 2/3 u to the 3/2. And we're evaluating at this, not using u, but using x's from x equals 0 to x equals 1. So let's keep going with that. We still have a pi. 2/3, I can cancel that with the 18 to get 9 here and a 1 there. So pi over 27. So now u was 9x to the fourth plus 1. And we're integrating that from x, or evaluating that from x equals 0 to x equals 1. So we get pi over 27. Now if you plug in x equals 1, I'm sorry, I left out my 3/2 there. That 3/2 came from that right there. So then we have 9x to the fourth plus 1. If we plug in x equals 1, we get 9 times 1 plus 1, so that's 10 to the 3/2. X equals 0, if you plug it in, just gives you 1 minus 1 to the 3/2. And so this gives us pi over 27 times 10 to the 3/2 is the same as saying 10 root 10 minus 1 and that's the answer for the surface area of this graph after you rotate it around the x-axis. So again, the key point there is identifying your f of x, running it through this formula, plugging it into the general surface area formula, and then we had a pretty tricky integral there. The key thing there was observing that the derivative of 9x to the fourth plus 1 was more or less x cubed, and so we could make this nice substitution that gave us a very easy integral to solve.